You can engineer the most robust, highly optimized backend infrastructure in the world, but if a single point of friction forces your user into a state of confusion, the entire machine grinds to a halt. Even a perfect smart contract is only as valuable as the transactions it processes. If a user feels a slight moment of uncertainty about where their assets are going, they stop the interaction. These individual moments of friction aggregate into the high drop-off rates that ultimately bankrupt decentralized platforms. This creates an immediate dilemma for anyone building a decentralized application. Do you hire a standard web designer to save your initial capital, or do you allocate a significant portion of your budget to a specialized Web3 design agency? The stakes dictate the decision. In traditional web development, a confusing interface might cost you an e-commerce sale. In Web3, a confusing interface leads to users permanently losing their own funds. In the decentralized landscape, the user interface serves as the primary security and trust layer for the entire platform. This chart maps different types of blockchain applications to show exactly where design risk is highest. We are measuring technical complexity against the requirement for mainstream consumer trust. Down here in the bottom left, we have developer-focused smart contract utilities. These require very little mainstream trust and rely entirely on utility, meaning they function with raw command line style interfaces. Conversely, consumer-facing decentralized finance apps, crypto wallets, and enterprise NFT platforms land in the top right quadrant. Applications operating in this high-complexity, high-trust zone face a zero-tolerance environment for UX errors. If a mainstream user feels a lack of control or transparency for even a second, they abandon the platform. The business cost of this confusion is an immediate collapse in user retention. Without an active user base providing liquidity and transaction volume, the platform's return on investment disappears. Succeeding in this quadrant requires a design logic that traditional web development agencies are not equipped to execute. This matrix compares standard web agencies against specialized Web3 teams. A standard agency begins by mocking up wireframes. A Web3 agency begins with a multi-step UX audit. Standard design produces visual layouts. Web3 design outputs architectural flow maps to guide irreversible, decentralized actions. This process involves a severe trade-off. Engaging a specialized agency extends your pre-development timeline and requires a much higher upfront capital investment. The classic tech mantra of move fast and break things works when testing social media layouts. But applying that philosophy to a blockchain application handling digital assets leads to financial ruin and a total loss of credibility. The heavy upfront time and cost of a Web3 design process acts as an insurance policy. It protects the platform against catastrophic user abandonment after launch. The most difficult hurdle in Web3 development is designing for irreversibility. When a user makes a mistake on a blockchain, there is absolutely no customer service desk to cancel the transaction. This flowchart illustrates security-first UX mapping for a token swap. Notice the path is not a straight line. Specific nodes in the journey are engineered with error state handling and secondary confirmations. These act as safety rails right before the user commits to a smart contract. This approach contradicts standard Web2 design goals. Traditional applications seamless one-click checkout to reduce friction. In Web3 security, you must deliberately introduce friction. Mapping out exactly where to deploy these friction points requires exhaustive usability testing. This technical requirement is what drives the higher fees associated with a specialized agency. While a developer might execute a SWAC using a raw command line, a mainstream consumer requires these intentional safety rails to feel confident enough to approve a transaction. By adding deliberate friction at the correct moments, decentralized wallets and exchanges increase their overall platform adoption and user trust. Beyond security, decentralized finance and staking platforms face a massive challenge in data visualization. Raw on-chain metrics, like gas fees, liquidity pools, and rapidly fluctuating yields, are completely overwhelming for a non-technical user to process. Solving this requires intensive, ongoing collaboration between teams. Founders must spend significant time educating the design agency on their specific token mechanics before a single wireframe is drawn. The goal of this collaboration is translation, taking that chaotic stream of data and structuring it into transparent, readable dashboard modules. This wireframe demonstrates the visual anatomy of a successful Web3 dashboard. Complex data points are isolated into distinct modules.
By separating specific metrics like yield performance, lockup terms, and REST parameters, the interface lets users make informed decisions without cognitive overload. A decentralized financial platform will only achieve high adoption if it successfully translates mathematical complexity into practical everyday language. Once the UX is mapped, the project enters the execution phase, where theoretical designs are handed over to developers to be built on-chain. This scorecard highlights the strict limitations of Web3 front-end architecture. The outputs are heavily constrained by what can actually be deployed on decentralized networks. Project owners must make a sacrifice here. Ultra-flashy animations are discarded in favor of functional, lightweight UI components that won't compromise platform stability. The design handoff must be fully developer-ready. Every visual component must align with the exact parameters and limitations of the underlying smart contracts. A specialized Web3 agency possesses the technical vocabulary to bridge the gap between the UI designer's visual ambition and the blockchain developer's technical reality. A visually stunning interface provides zero value if the on-chain front-end realities make execution completely impossible. To decide if your project requires the premium cost of a Web3 design agency, we can use a decision framework. The first fork is your target user base. Are you building a tool for developers or a mainstream, non-technical audience? The second fork evaluates the platform's primary function. Are users engaging in complex financial transactions with high stakes, or are they utilizing a basic viewing tool? If you are a bootstrap team building a basic blockchain utility like a block explorer aimed strictly at technical users, avoid hiring a specialized agency. For these specific teams, diverting limited initial capital away from back-end development to pay for a 9-step UX strategy process is a waste of resources. If your audience only cares about the raw performance of the smart contract code, paying a premium for consumer-grade usability is an unnecessary luxury. However, if you are an enterprise leader or a team launching a consumer-facing decentralized application, investing in specialized Web3 design is a mandatory requirement. Projects dependent on institutional trust, like B2B supply chain trackers or real-world asset platforms, cannot risk confusing their business partners with clunky, intimidating interfaces. For consumer-facing Web3 apps, the ultimate design goal is invisibility. The interface must be so seamless the end user never realizes they are interacting with a blockchain. Allocating a premium for specialized Web3 UX serves as a critical investment in risk mitigation and long-term platform viability. In decentralized systems where mistakes are permanent and support doesn't exist, clarity is what guarantees security. A Web3 design agency illuminates the precise steps to move through the protocol. This lets users accomplish their goals without understanding the technical overhead. In the Web3 space, if your interface requires a tutorial for users to avoid losing their money, the design has already failed.